When graphing a logarithmic function, one of the more important things you need to know is what the vertical asymptote of that function is. You can find this out by finding the domain of the function. Remember, that's just taking the argument and setting it greater than 0. You can use the various transformations to graph these functions, but a TI-83 or 84's table function will work extremely well. If the calculator you have doesn't have a table feature, you can just plug in values into the function and get your points that way. Now, many calculators do not have the ability to do different bases, so I'm going to actually limit my examples to base 10 and natural logs. So the first one we have, f of x equals log x minus 5, and we're going to graph this. But first things first, I want to know where the domain is so I can get its vertical asymptote. So the argument is just x. So the domain is going to be x is greater than 0. That's all we do. We just take the argument and set it greater than 0, which means by default, its vertical asymptote is going to be x equals 0. So I can go in here and graph my vertical asymptote. I'll use red to signify it, and as a dotted line so I know I'm not graphing it, right here. Now that I have done that, I am actually going to plug my function into the calculator. So I'm going to take my calculator here, and I'm going to plug in my function. So plug in the function into y equals, and I'm going to do log x minus 5, like so. So I hit second and window to make sure my table starts at 0 and 1 and everything's set to auto. And then hit second graph to get my table. Now you can see here at 0 is an error, and anything to the left of 0 is an error. So that just proves that the domain that we found is correct. So I'm going to use the first 3 points just to graph it. Most of them are decimals, and that's just the way it works with logs. So the first point I'm going to use is 1, negative 5. Then I'm going to do 2 and negative 4.7. And I round to 1 decimal because graphing anything more than that is pretty much futile. And then last I'm going to do 3 and negative 4.5. So I got 3 points, so I'm going to graph those. So 1, negative 5, 2, 3, 4, 5. 2, negative 4.7, just a little bit higher than that, right there. And then 3, 4.5. A little bit higher than that as well, not by much. And so I can see this is kind of have a slight increase. And so since this doesn't exist over here and has a slight increase, this is going to go up along the vertical and then connect the dots and kind of increase at a very slow pace. So that's what the graph looks like, but let's make sure. Let's go in here and press graph and see what it says. Kind of says the same thing. Very slow increase. So I feel pretty good. Now again, if you don't have the table function, not to worry, we can just type in our numbers the old-fashioned way. We can just do log of 1 minus 5, and there's negative 5. Then we can do 2, so we can say log of 2 minus 5, get you the same negative 4.7 rounded. And we can do log of 3 minus 5 and get negative 4.5 rounded. Now make sure you close the parentheses off, because if you don't, it will give you an answer and it will be wrong. So be mindful of the parentheses, especially when it comes to logs. So let's look at this next one. F of x equals 3 ln of x plus 2. So I'm going to find my domain. So the domain is going to be x plus 2 greater than 0. And we're going to solve, and we're going to get x is greater than negative 2. So there's my domain, which means that this will give us our vertical asymptote at x equals negative 2. So I'm going to graph that at negative 2. So right here, dotted red line, just to show that's where it is. And now I'm going to plug my function in so I can get some points. So back to y equals, clear out the old one, get rid of it, and let's plug in the new. 3 ln of x plus 2. So there's my function. It's at 1, I'm going to set it to 0, and it's still 1 in all auto, so now I'm going to graph it. And I got a bunch of really terrible decimals, but I got a nice point there, and there's my errors again at the vertical asymptote, all errors, so we know, again, proves just the domain is anything more than -2. So I'm going to start off with a nice point, -1, 0. So let's switch back to black. So -1, 0 for the first point, and then 0, 2.1 for the next. And for the last, I'm going to do 1 and 3.3. So I got 3 points here, so I'll graph those. So -1, 0, 0, 2.1, right about here, increasing a lot faster than the previous one, and then 1, 3.3. So that's about here. So these are increasing pretty quickly compared to the last one. So we see our basic shape like so. And so we draw our line going up the vertical and then connecting our points, and it just kind of goes off. Something like that. But is it right? Let's see. What does the calculator say? Calculator, more or less it looks right. It's not 100% right, but again, you're not a computer. No one's expecting you to graph it like a computer. So just get some points that are reasonably close like this, round it to 1 decimal, connect them in the right shape, and you're good to go.